Hello. Hello. Okay. Okay, so the noise you hear in the background is actually from my laptop fan, which is running at max speed, I think. So yes, it will be for a while only, and then it will quite. I think. Okay, so welcome to another stream. It is Thursday, and we are starting early today, I think. Yeah, and we'll be starting with this problem, gth problem. And before that, let me make a file. Yeah, it is dull stream, I think. And let me bring my template. Okay, we don't need this. We don't need these two. Okay, this is optional. This is required. Okay, and yeah, instead of this, we'll just do this. Okay, so we have our template ready, and longest path. Okay, this board will be deleted after 37 minutes. So let's solve that problem within 37 minutes. Longest path. Okay, so what does the problem say? There is a directed graph G with n vertices and m edges. The vertices are numbered 1, 2 to m, and for each I, where I is less than equal to m greater than equal to 1, the ith directed edge goes from vertex xi to yi. G does not contain directed cycles. Okay. Find the length of the longest directed path in G. Here, the length of a directed path is the number of edges in it. Okay. So we want to calculate the longest path. That is our objective here, and we have the graph here also. And see, we have one is has an edge to 2, one also has an edge to 3, three has an edge to 2, and 2 has an edge to 4, and 3 has an edge to 4. So the longest path here, what is the definition for the path here? Okay, like this. So the maximum edges from between two nodes, right? Since there is no cycle, so yeah, this will work. Maximum edges between two nodes. It's a DAG na, directed acyclic graph. So in DAG we can in DAG what we can do is uh, say we are starting from 1, let's say. Okay, so in that case the maximum distance or the longest directed path from 1 to 1 will not have any edges, right? Because there is no self loops, there's no cycles and also it will be 0. When we are at 2, we need to check for all from where we can reach to and what is the maximum distance then. Okay, or rather we can do from 1 itself we will push the states. So from 1 all the neighbors will be given 1, since that is the number of edge from 1 that we will have from 1 to that node, right? And when we are iterating that, let's say uh, but that doesn't mean every time it is going to be like that, right? Okay, so initially all the states will be 0 and we'll start from 1, and it will be, since the graph can be disconnected graph, right? We can have, for like in this example, we can have a graph like this. So we'll run in all the components. Okay, and from the component or other than that we'll just, yeah, let's just forget about all of that. We'll just make a we'll just topologically sort the graph and then do the iteration. Okay, so what is the topological sort for this? It's 1 3 2 4. Okay, and in this topological sort 1 will be assigned 0. Okay, and since from 1 and 3 there is only one edge, so it will be 1. 3 to 2 it is 1, so 1 plus 1 it will be 2, and 2 to 4 it is 1, so it will be 3. So maximum will be 3. Topologically sorting, since there is no cycle, so we can have an order which represents the we can have a sorted graph which represent the order of nodes such that the previous node before the current node always processed before that. And I hope that you get what I'm trying to say. So whatever node comes before 2 is always going to be processed first, right? Even in this graph, since that comes first and there is a directed edge. So yeah, we'll do a topological sort and then we'll update the DP. So how do we do the topological sort? There are two options. First, we can do a Khan's algorithm. That is one way, And second is we can do uh, second is we can run a DFS, and in that DFS we can do the like DP state update. Okay. So suppose we start from 1, right, in the DFS, and we reach 2 and 3 in the first iteration. So we'll first update it as 1 and 1 only, and from 2 to 4 we will reach here, so that will also be updated as 2 only. But then again we will have to traverse it multiple times, so okay, we just want to make a DFS list right first. So okay, by any means we'll get the DFS. But whatever DP state holds, right? So we'll have a DP I. It basically represents the longest path till ith node, something like that. And this is the state. Our base case will be dp I is 0 for all I less than equal to n1. Okay, transition is simple. We're just going to once we have this list, right, we are just going to push the values to its reach. Basically from 1 we can go to 2 and 3, right? So we'll push that here, and then when we are at 3 we'll push that also. So it will be 1 plus 1 2 will be pushed here, and 1 plus 1 2 will be pushed here. So we'll choose the maximum out of this. So yeah, transition will be like this. From dp y I is equal to maximum of dp x I. Okay. dpxi plus 1 and the dpyi itself. Okay. So this is kind of like this. And answer will be the maximum of all DP states. Okay, so I don't think we need to get that topological sort here also. We can do that from here only. I think. But how? Yeah, let's try. We have the number n, m, and x, n, m, and then we can just have a dp of n plus 1 state or initialized to 0, and for all the pairs we get, we'll just do I'm using a lot of memory here since I'm doing everything in LL long, so that can be optimized, but I'm not going to bother with it. Okay, and then we'll do dpy is equal to dpx plus 1, and this is maximum, and for this okay. Three, 2, and we need one more 3. Okay, this looks good. Let me just check it. Oh shit. What happened? Yes, I'm human. Okay. Wrong answer. TLE, MLE, WA, MLE, TLE, anything. Okay, wrong answer. See, I thought that we could do it. Let's see how many test cases we got right. Oh, 4 only. Damn. Okay, so yeah, we cannot do it. We'll need to we will need to do using that topological sort only. Okay, so how should we do it? DFS or Khan's algorithm? Khan's algorithm is kind of lengthy, and DFS takes stack memory, but also we'll have queue in stack Khan's algorithm, so I'm not sure. Let's just do a DFS, and it is going to be a wide DFS. We'll have the source and we'll also have a we'll have source. Okay, it will work. If with src return okay, then we need an adjacency list as well. And I will have to give a size to this row. Just enter the bar 5 anyway, I think. Okay. For auto node in adjacency src, if not visited the node, then visit the node, and when you are done, we'll have the topological sort. ts.pb your src. So once we have the ts, okay, adjacency x.pb y, and for where we have at least okay less than equal to n. If not visited I, then just do the DFS. After this we'll have the TS topological sort, and then for auto I or auto node in TS, and for auto node in adjacency of I. We are just going to do the same thing that we did here. So it will be dp of that node is equal to maximum of dp of node comma 1 plus dp of I. Okay, and the answer will be maximum of dp node. Okay, let's see. In just a second. I'm muted, bro. Sorry, I forgot to unmute myself. I said a lot of stuff, I think. Uh, I hope that you got the solution that I did with solution for this one. And yeah, okay. So it's like it was similar to that CSES problem. So I don't think there is any problem. Oh, and I was discussing this coins problem, and yeah, of course I was wondering about why they have a very clever way of writing 1 to n, because no matter how you read it, it's 1 to n only. And I was also thinking about this, the why there is so like what is the word for it, why there is so much emphasis on this n being an odd number. So I was wondering this, and also remembering some past times, my school days when I was in my prime for math. Okay, so thing is, okay, what will happen if this timer pass? Icoins. So we are given let's take an example. We are given coins, and what is this? It is basically probabilities of them, their head, I think. Yeah, probabilities of the coin if tossed. This will be the probability of coming up with that coin coming up with a head. Okay, so the answer what we want is find the probability of having more heads than tails. So basically, since this is an odd number, we can divide heads and tails. Okay, so let's say let's 3, right? So we want here 2 tails or 3 tails for the answer. So it will be the what? Find the probability of having more heads than tails. So it will be, it will be the sum of these. So we need to run a loop from n plus 1 by 2 to n. Okay, so we need to run a loop from this and then calculate for that, and then update our TP or whatever. And that is what I'm thinking. So let's take an example for this, a good example, like this. Let's say we have this one here, and this is 5, so we'll be running the loop from 3 to 3 to 5. So we need 3 heads, 4 heads or 5 heads. So since there is a OR, right, so it will be addition only. In the school times we have read that probability when there is an or it is added, and when there is an and it is multiplied. Okay, so yeah, so it will be added. So we know the answer will be like this: n plus 1 or summation of dpi, where I goes from n plus 1 by 2 to n. Okay, so this will be the answer. We know this much, but how do we calculate for a single I? That will be the main challenge here. So our dp I is nothing but probability of getting one heads. Out of n coin tosses. But then again okay, so the thing is that we'll have to add all these things. Okay, we'll have to add all these things. So for 3 also, we will need to check for all the possible combinations and then add it. Okay, so it's going to be a 3 loop. And I'm not sure if this will work because the constraints are 3000. So for sure this is not going to work. Or maybe it will work. Okay, let's think about how to calculate the DPI. Okay, so if we have something like this, right? So to calculate getting one head, okay, so that will be either this is head, this is head, this is head, this is head, this is head. So we'll just add all of this. Okay, to calculate if it is 2 head, So for that we'll need to check the combination of 2. We need to check the combination for 2, and if it is 3 we need to check the combination for 3. For 4 it is 4, and for 5 it is 5. So it will be like a factorial time complexity, and to reduce that we will have to only have 2 states, right? So I think our DP needs more states. I'm audible right now. Okay. So for 1 we can do this one. And just try to think recursively, and maybe then we can go to top bottom approach. So DP will have an I is basically the index of the coin right now, and then we'll have the number that we want, how many times we want to appear. Okay, and then we'll have okay, then we'll have nothing. Okay, so we have this, and from here we can go. For example, if we want it for 1, let's say we are at 1. Okay, so let's say we are at 2 now. We want 2 heads. What is the probability of 2 heads? Total probability of 2 heads. So we'll start from all the elements, that is n, and this is let me take it as 2. Okay, so it will first try to select the last element. If it selects, then the answer will be nothing but the probability of that element times our dp I minus 1 and t minus 1. Okay, the other thing is that we don't select it, so it will be 1 minus pi, and then dp I minus, then dp I minus 1 and t minus 1. So similarly here also this dp we will either choose or not choose. So let's say I chose this one, so I minus 1 into dp I minus 2 and 0, since it is now 0, and here 1 minus p I minus 1 into dp I minus 2 t minus 1. Okay, so something like this. And here also we will have dp we chose this one I minus 1, dp I minus 2 and 0, or t minus 2, and we didn't choose this one, so it will be dp I minus 2 and t minus 1. So I think we have repeating. Okay, we have repeating values, right? So we can apply dp, we can apply some memorization here. So how will the dp state work? So we'll just do some changes. Okay, and here it will be n only. Not n, rather g, and again this will be g. So we see how the transition will go, right? So the transition will be dp ij is dpij is we select we select the coin or we not, but for the base case for when I is equal to 1. Okay, so for when I is equal to 1 and we have all the tosses, in that case the answer will be summation of all the answer array. Okay, but the probability cannot exceed 1. Okay, so that we'll have to do something about it. We cannot have the probability exceed 1. So for that matter, we'll start from n plus 1 by 2 only. So there is no state for 1 to n by 2. Okay, f n plus 1 by 2 minus 1. So everything will be 0 before that, and the moment we are there, we'll be solving. But what will be the base case then? So from the recursion tree we can see that if the dp somehow reaches the last element, that is 0, and also if we don't have any need, we don't have any coin and we don't have any requirements, any heads, we don't want any heads, then in that case anyhow we can just return 1. For all these cases we can return 1 because it's a multiplication, it won't matter. Okay, if we don't have any coin, and we need one head, if we multiply any branch with 0, it will be also. Why am I doing it like this? Achha, okay, so what am I going to do with my choices then? Since I have 2 choices, what am I going to do with my choices? Should I add them? I don't think we should add them because we should not add this, or should we? Okay, so if we cannot reach it, if we this case will be 0 and that whole branch will be 0, so it won't be added. We'll add these things. I'm afraid of just one thing, that it doesn't exceed 1. It should not exceed 1, right? Okay, if this thing is 0 and this is not 0, so we'll just return the ith value of it not coming at. Okay, since we don't want to uh, affect the answer for, since we only want to get t heads, right? So we should get all the remaining coins as tails only. Okay. Okay, so we have the base case. If I is 1, if I is, okay, we have the state reversed, right? So we'll do it according to our state only. So I is basically the amount of t required, amount of heads, number of heads, sorry, by amount, number of heads required. So we'll set the base case and it will be 1 if I is 0 and j is 0, and it will be 1 minus pj if I is 0. It will be 0 if j is 0. Okay, and the next thing is it will be like this. We select the jth coin and also take the answer from the last one, go to the last one, plus we don't select it. Select the appropriate TP and multiply it together, j minus 1. Okay, if there is no way of doing this, any one of this path, it will be automatically set to 0, since that is how our base case is. Okay, so yeah, anyhow, this is, and we'll need to check if I minus 1 j minus 1 is valid or not. Yeah, okay, so let's go and implement it. We already have the, okay, we don't need this, we need this only. And we'll need double. And before that we have the array dp, and dp will be of size what? We are going from this should work, and all the value initially is 1, and then we'll do the what? Run the loop. For I is equal to 0, I less than equal to, where are we going? N, I plus plus, for j is equal to 0, j less than equal to n, j plus plus. Okay, so if I is double equal to 0 and j is double equal to 0, then dpij is 1. We already have that. Else if I is double equal to 0, so the dpij is 1 minus p, and j minus 1. Sorry. Else if j is double equal to 0, in that case dpij is 0, and else dpij is pj minus 1 multiplied by dpi minus 1 j minus 1 plus 1 minus Is it okay to do 3 memory access? No, I don't think so. We'll just stick to this basic one for now. Multiplied by dpi j minus 1. This should work in theory, and we have the answer, and for that we'll run I from n plus 1 by 2 till n, and answer plus equal to dp I n, and see out answer. And do we need to set precision or what? Set precision 6, 8. Let's see. First TLE, MLE, anything. Okay. P was not declared. Now P is declared. And wait a minute, it said that it is decimal na, so we need to do this 0.672. okay, how about this one? 0.5. okay, this one is okay. Clear to 1. Why is it not working? I thought the logic was correct, and I still think it is, but what is the issue here? Is there any issue in the transition? 468 144. It is correct. What about this one? 378402. Okay. 0.7. Probability of getting 4 heads should not be this much, bro. Let's see. 0.42. We have this now. 0.42 multiplied by 0.01 multiplied by 0.42 again multiplied by 0.99. 5C4 is basically 5 only. So 0.42 again 0.42 0.01 multiplied by 0.42 and this one 0.01 0.42 0.99 0.42 and we have 0.42 0.42 0.42 0.99 and in the next one we have 0.01 0.42 0.99 0.42. Let's see. Just copy this, right? Okay, plus okay plus okay plus plus okay plus okay. So it is close to this. And what about 3? 5C3, 5C2. Okay, this is a lot. It's like 10 different ways. So I'm sure we can get this much. So yeah, then this and then this. Then the answer will become this only. Why in the why I'm getting this then? Okay, what is the attribute for it? No attribute. Oh, greater than na? But it will be greater than. Okay. Okay, so if we don't need any heads, here J is the indicator of that, right? So this is not, this is it, no, should not be 0, but rather if J is 0, then the probability will be basically it will be that yeah, it will be like we don't need any heads now, we only need tails. So all the tails that we can get from all the previous elements, right? What is the probability for that? So that is the, yeah, so wait a sec, I think I is here the, okay, I is the number one, so we did a mistake here. Not this one, but rather this one. This is correct, but we need to multiply it with dp, and again similar I, and then j minus 1. Yes, that was the issue, bro. Code was correct. This base case, fuck, this base case here, where is it? This thing, we have dp and I and j minus 1 when your I is 0. So whoever is this, Neil, no, not Neil, who is this? Code explainer. Thank you very much, bro. Thank you. Okay, so yep, we are done now. Let me just remove this. Okay, it is 9, so 9. Let me check other test cases as well. Okay, what this one? Working fine. Just copy it and place it. I need to make a proper guide for this also, because this solution is very easy. The solution that I did. Of course, the base case was wrong. And yeah, see, AC. Okay, so we did 1, 2, 3. Only 3 problems. Damn. Sushi. Okay, we'll do sushi tomorrow. But tomorrow is Friday and the start of the weekend, and we'll do sushi then, tomorrow then. Okay, so yeah, we did solve 3 problems today, but I don't think that was enough. Most of the problems were like I already had solved it in some way or another. So yep, this probability one was not new, but a little different than the others. Okay, so yeah, and of course I forgot to unmute myself for like, I guess 30 minutes maybe, so sorry for that. And yeah, So this was it for this stream, and I hope you have a good night and peace.